Welcome, my dear students. Welcome back. Welcome, my dears. Welcome back to another part of the financial math. This part is about the present value of one sum and the present value of the annuities. So we have here the present value. What the meaning of present value? As example, you will pay a mortgage of $1,000 starting from 1 year from now. So as example, you will pay $1,000 after 1 year, then $1,000 after 2 years, like here, then after another $1,000 after 3 years, and $1,000 after 4 years. And we need to know the value of each of these right now. Okay, the mean or what we will do now is just multiply the 1,000 times 1 plus the rate, power minus 1 for 1 year, power minus 2 for 2 years, power minus 3 for 3 years, and power minus 4 for 4 years. This shows like this way when I come to do it. So as example, let's say for 1 year. For 1 year, I say that the present value for 1 year, I would say that the present value will equal, let me just enlarge it so that it will be fine, shown up for everyone. The present value will equal what? This P value, let's make PV, means present value, will equal the principal multiply by 1 backslash, that is 1 plus rate of interest, it's in compound rates, and that will be power the time, or the n. N is the number of years or the number of deposits, whatever we have in the example. So as example, the PV here for the first amount, like here as example, if we see here the present value for the first amount, as it looks in front of you here, it's 1,000 and it's for 1 year. So that's what I will say here again, will equal the principal is 1,000, then it's multiplied by, let's say 1 backslash. If I have now 1, again, is constant inside the equilibrium itself, plus the rate of interest is 0.04, and that is the power of this relationship. The power is 1 year. Guys, the same thing is like if I remove this relationship, which means like this way, it means 1,000 divided by slash by 1.04 power 1. Same likewise, it's the same thing, which is here will equal again Control and C, that will equal Control and V, but here will be power minus 1. So for the first year, it's power minus 1. For the second year, it will be power minus 2. For the third year, so this is for the first year, Control and C, that will be for the first year, as it's shown up here exactly in front of you here. Here it is. For the second year, it will be power minus 2. For the third year, it will be power minus 3. For the fourth year, it will be power minus 4. Let us do it here in front of you also written. Same thing here. It will be, but as long as I did here, that will be asterisk. So because this is multiplied. Here it was division. For that reason, it was positive because there was division here, dividing. But here now, when I change it into minus, because I multiply by the same amount. So the same divided by 1 plus 0.4 power 1 because it's division. But when I want to convert this division into multiplication, then it will be power minus 1. Likewise, for the second year, same equation, but it will be power minus 2. Same thing for the same equation, Control and C. For the third year, it will be power minus 3. Same thing for the equation for the for year 4, it will be power minus 4. You guys also can do it by this way. You can say 1,000 multiplied by 1 divided by 1.04 power 1. So when you do division also, it's the same. But minus because I converted from multiplication into division, from division into multiplication, like the way you see here, like the way you see here. Okay, this is minus 4. Then back to track, back to the exercise. So this amount, power minus 1, will be, this amount will be 961.54. And power minus 2 will equal, when we calculate it, 924.56. And power minus 3 will be the third amount, 889.00. And the fourth amount minus 4 will be 854.80. When we add them up together, the 4, that will give me this amount. Okay. But since this is an annuity, the annuity here is similar, which is $1,000. And it's ordinary means at the end of the year, because it's here at the end of the first year, and at the end of the second year, and at the end of the third year, and at the end of the fourth year. As long as it's in the end of the period, that means I can use the formula of the annuities, the ordinary annuities. Here is the formula of the annuities. As long as I have the same amount, which is $1,000, and the time is 4 years. We have here 4 years, or 4 sums. This is the first sum, second sum, third sum, fourth sum. Each sum of them is deposited at the end of each year. At the end means it's ordinary. At the end means it's ordinary. For that reason, we have similar annuities, 1,000, which is similar to each other. And we have the duration is the same, didn't change, 1 year, 1 year, 1 year, 1 year. And it's ordinary because it's at the end of every year, ordinary. So we can apply directly this formula, which will give me the same results when I did it one by one, manually. For the first year alone, second year alone, third year apart, fourth year apart. And I got this result. So this formula replaces all these steps. For the 4 years, it replaces all of them. And instead of doing them one by one, once at a time, I can do all of them with the formula, which say the present value will equal the principal of the annuity multiplied by 1 minus 1 plus the interest power minus n, which n means the number. N here means the number of the annuities. We have 4 annuities here, 1, 2, 3, 4. Like you see here, 1, 2, 3, 4. We have 4 annuities. Like you see here in front of you, we have 4 annuities. So minus 4, here it is, minus 4, divided by, again, the interest rate. The interest, of course, is a compound interest here. So you finish it by the calculator. The principal is 1,000, or the number of the annuities is 1,000. We have the interest rate of 4%. So here we'll say 1 is constant, 1,000 multiplied by 1, which is constant, minus 1 is constant as well, plus 0.04, which is the interest rate, power minus 4, minus n. and N we said are for annuities. N annuity divided by I, which is the interest rate. Once I'm done for the calculator, and once I'm done for the how to calculate it, then it will give me 3629.90 cents. 3629.96 90 cents, which is the same results when we did it as a simple annuity. So in the first calculation here, which is this one, we did it as simple annuities, and we did it like one annuity, and we calculated at the end of the period. But why shall I do this? As long as the similar, I have the annuities are the similar. Annuities are similar here. Annuities are similar. And I have the duration is the end of each period, which is 1 year. And I have 4 annuities, and the interest rate is 4%. So I can apply directly the formula, which is in front of you here, guys. And this is the formula for the present value for ordinary annuities, simple annuity. So this will give me the same, which I got for each one apart. The next step is just another examples on how to calculate the ordinary annuities regarding this part. Shall go to the next part. Thank you.